Hello class, welcome to lesson 4-10. Today, strong mathematicians can identify factors, multiples, and prime and composite numbers. So some vocabulary words that we're going to work on. It's 2-day lessons. We're going to break it into different parts. So take out your notebook, your pencil, and you write down today's date and the name of the lesson, and let's get started. So in box 1, our vocabulary we have is multiple. What is multiple? It's a number that is the product, so product we know multiplication, of a given number and any whole number. So there's a lot of numbers on there, so try to make sense of all those numbers. What do they mean? So if I would say the number, for example, 4. Is 4 a multiple of 4? Well, the answer is yes, because 4 times 1 equals the 4. So now the question would be, is 8 a multiple of 4? So I think, is 8 a multiple of 4? So 4 times what could give us 8? If we can find that, like 4 times 2 equals 8, then 8 is a multiple. Is 12 a multiple of 4? Well, the answer would be yes, because why? 4 times 3 gets there. So if you kind of look at it, we have two numbers. So we have 12, we have 4, a multiple. So I think of 4 times what equals 12. If we can find something that works, it is. If we can't find a whole number, then it's not a multiple of 12, or of 4. 12 is not a multiple of 4. There we go. All the words in the right spot. So you can pause the video, write down this information to kind of help you out, figure out what a multiple really is and what it means. So write the first 10 multiples of 6. So if the first 10 multiples, start with the other one. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 54. And 6 times 10 is 60. So notice we were going through that I did each of those separately versus kind of, if you notice, they each go up by 6 because, in a sense, you're adding 6 to it. But I don't like to do that. I like to think of them as each a multiplication equation, because if I mess, let's say, this one up and I would have put 29 and I would start adding 6, well, then all these multiples are going to be incorrect. So that's why I always think of them as multiples. So I give myself always multiple equations to work on finding the multiples. So I'm going to ask ourselves here, is 6 a factor of 40? We know factors are the parts that make up a multiplication equation. So is 6 a factor of 40? Does it mean 6 times something equals 40? A whole number. So 6 times something equals 40. Well, I'm looking, I see, is there the number 40 in my multiples? Well, 40 would be right in between these two. So there's not 40 on there. So is 6 a factor of 40? The answer would be no, because 6 times, there's no whole number that I could use to get to 40. So next one is 54, a multiple of 6. So it would be 6 times something equals 54. Well, the good news is, in my list of multiples, I see 54. So yes, it has to be a multiple. And what would that be to answer that equation? What would be the multiple of it? It would be 9. 9 times 6 is 54. So is 54 a multiple of 6? The answer would be yes, because it's in our multiples of 6. So you can pause the video right now, write this information down to help you out. As we continue on, tell whether 8 is a factor of each number. So is 8 a factor of each number? So we can start writing this out. We could start doing our multiples. 8 times 1, 8 times 2, 8 times 3. And we list every single one. That's a possibility we need to go. We have to go as high as 96 because one of our numbers is 96. So we know, is 8 a factor of 8? Well, if the number is asked if it's a factor of itself, the answer would be always yes, because we know that number times 1 would give us that. Yes, why? Because 8 times 1. Now if you look at number 96, that would take us a long time to get there. So we know that if it's a factor, then we should be able to divide 8 divided by 96. If it comes out evenly, then we know it's a factor. If there's a remainder, then we know it's not a factor. So 8 can go into 9 once. 8 times 1 is 8. Subtract it gives us the 1. Bring down the 6. 8 can go into 16 2 times. So is 96. So that would be 16. I'm going to subtract to give 0. There we go. So we don't have a remainder. That means 96, yes, is a factor because why? 8 times 12. So we'll try the next one. 87. So 8 divided by 87. 8 can go in there 1. This would be an 8. This would be a 0. Bring down the 7. That's too small, so it would be a remainder 7. So the answer would be no. 87, 8 is not a factor of 87. Or we could have kept going with our skip counting for this 49. This is another way to show you different ways that you could find, are they factors of the numbers? So we get 8, 16, 24. 8 times 4 is 32. 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. I can stop there because 49 is not in there, so the answer would be no. 49 is not. 8 is not a factor of 49, or 49 is not a multiple of 8. So that's one way you go with this one. We also talk about seeing patterns and number patterns. So you have 3 times 12 is 36. We have 4 times 12 is 48. So if we keep going, 5 times 12, well, this is adding 12 and going up by 12 because we have one more group of 12. This will give us 60. We have one more group of 12 would be 72. And one more group of 12 would be 84. So it's really important that said you double check your work to make sure, is there 12 between each of these? Because over here it's one more group of 12. Another group of 12, one more group of 12. So just make sure that these are always going up by 12. And number 6 over here, we got skip counting. So we're going to rule skip count by 7. So in a sense, we're filling in these blanks, but we're counting and going up by 7. So really, 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. Good, so I'm still on the right track. 7 times 5 is 35. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is 46. 7 times 9 is 63. 7 times 10 is 70. 7 times 11 is 77. 7 times 12 is 84. And 7 times 13 is 91. So notice we skip count as many. We could skip count on and on and on if we want to, but that's how you would skip count by 7. Notice I went through each of them. It's kind of a multiplication equation. It's kind of what skip counting is all about. So you can pause this slide right now, write down all this good information, and go through it and listen to it again if you have to really help you understand how to find the factor of each number, how to skip count, how to keep the pattern. And those things will be helpful as we move to the next section. Now it's your turn. So right now you can write down the first 9 multiples. Make sure you draw a big line. Write down box 3. Now your turn. And right now I want you to write the first 10 multiples of 9. And then put number 2. Is 9 a factor of 54? It would be yes or no. And is 64 a multiple of 9? Yes or no. So you can pause the video. Good luck. And we're looking at these now, but tell whether 6 is a factor of each number. If it is a factor, yes, I'd like to know what multiplication equation you used. For each of these numbers, if it's no, then you can just write the answer no. But is 6 a factor? 6 is 72, and so forth. We've got some 3 times 13, kind of some pattern right there. And number 6, we're going to skip count by 9s. So you can pause the video, write down this information, answer it all really nice and neat and labeled so I can follow your work. And good luck and do your best. As always, if you have any questions, comments, or concerns, feel free to write them down or share them out. Also, if you have any strategies that you use to help you, make sure you include those as well to help others who still might be struggling. As always, thanks again for another great lesson.